An alkane having a molecular mass of 72 produces only one monochlorinated product. So out of the given 4 options, what is that alkane? To answer this, first let us write all these structures in terms of carbon and hydrogen and check out how many of them are satisfying the statement molecular mass 72. So this is option A, CH3, CH2, 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 CH3, isn't it? This is the first carbon, second, third, fourth, fifth. This is the carbon skeleton. All the remaining valencies are satisfied by hydrogens to get this particular structure. Let us write for option B. I am starting with this carbon. This carbon is attached to 2 carbons on this side. So let me write them separately. And 1 carbon on this side. And that carbon in turn attached to 1 more carbon. It is like this, the carbon skeleton of option B. Then all the remaining valencies are satisfied by hydrogen. So this is CH3, this is also CH3. As this carbon already formed 3 bonds, only 1 more hydrogen is need to be written here. It is CH, this is CH2 and this is CH3. Now the structure for option C, it is like this. 1 carbon at the center and 4 carbons on 4 sides and 1 carbon each on these 4 sides. And on writing the hydrogens, we get the structure like this. And for option D, it is like this. It is a cyclic compound. So now what next? So once we are ready with the structures, we need to check out for how many options the statement molecular mass 72 is satisfied. If we observe clearly, option A, B and C, these 3 are the isomers. They are having the same molecular formula but different structure. And the molecular formula becomes C5H12. Check out all these options A, B and C. They are satisfying the formula C5H12. And the molecular mass of this pentane is 72 because atomic mass of carbon is 12. So 12, 5, 60 and each hydrogen is 1. So it becomes 72. So molecular mass 72 is satisfied for all these options A, B as well as C. Now let us write the molecular formula for this one. It is nothing but C5H10. So whenever it is C5H10, the molecular mass will be less by 2 units. So it is 70. So definitely this cannot be the correct option. Now let's read the remaining part of the question. Which of these 3, that is among option A, B and C, only one monochlorinated product is formed? Means in how many ways we can remove one hydrogen to write a monochlorinated product. Let us see in option A. We can remove hydrogen from the left hand side carbon or from right hand side carbon. So in both the cases we get the same structure. So let me write it as 1 for both of them. Then from left hand side you can substitute 1 hydrogen on the second carbon with chlorine or even from this particular carbon. Both gives the same compound. So till now 2 possibilities are there or 2 monochlorinated products are possible. And again we can replace the hydrogen on the third carbon to get 1 more chlorinated product. So for this particular compound, for this particular structure of pentane, 3 monochlorinated products are possible. So that cannot be our answer. Let's see option B. So for option B, if we replace the hydrogen of this carbon or this carbon, we get the same compound, isn't it? Then you can also replace from the second carbon and also from the third carbon and also from the fourth carbon. Remember one thing, all these 3 CH3 groups are not identical, isn't it? Because when we replace one of the hydrogen of this carbon by a chlorine group, we get a methyl group as a substituent at the second position. But if we replace one of the hydrogen on this carbon with the chlorine group, we get the methyl group as substituent on the third carbon, isn't it? So both are completely different. So for option B, 4 different monochlorinated products are possible. Then for option C, there is no hydrogen on the central carbon and all these 4 carbon atoms are identical. So if we replace from any of these carbon, we get the same product. So for this particular structure, there is only chance of one monochlorinated product. So the question, an alkane having a molecular mass of 72 producing only one monochlorinated product, that is option C. Is it clear?